Hello and welcome everyone. This is the start of a brand new series where we're going to learn about computer networking from the absolute basics to writing our own code. In this first video, we're going to answer the most fundamental questions about what is a device on a network, what are we even trying to do, and what on earth are these mysterious numbers called IP addresses and ports. So let's start with the absolute foundation. What is a device? In networking, a device is anything that can be connected to a network. This could be your laptop, your phone, your smart TV, a security camera, or other similar things that can connect to a network. The key thing is that each device can both send and receive data. That's the entire goal of networking. The goal is to transfer data from one device to another device. That data could be an email, the content of a website, a video stream, or a message in a multiplayer game. It's all just data getting from point A to point B. So the main question here is, how the data know where to go? If I send a message into a vast internet, how can I make sure it's not going to get lost and end up in the wrong person's hands? That's when the two main characters come in, the IP address and the port number. Let me give you an example. Let's say you want to send a physical letter to your friend. You can't just write the name of your friend on the letter and throw the letter out of the window and hope it's gonna reach him, right? You need to write down the address so the postal service could bring it to your friend. In networking, this is the IP address. An IP address, which stands for Internet Protocol Address, is a unique label assigned to every device on the network. It is a unique location. So IP addresses are usually shown in this format. This format is called IPv4. There is a new version called IPv6 with longer addresses, but we'll stick with IPv4 for now as it is still the most common. So the IP address is gonna get our data to the right device, but that's not the end of the story. Let's go back to the example of sending a letter to a friend. So when you write the street address on the letter, the postal service knows which building that letter should go, but that building might have a lot of different apartments. We also need to know which apartment this letter needs to go to. This is where the second concept comes in, and that is the port number. It's a way for a single device to manage multiple different connections or services at the same time. Think of your computer right now. You might have a web browser open to watch this video that uses a port. You might have a music app running in the background that uses another port. You might be logged into a game that's also going to use another port. So your computer needs to know that incoming data for the game should go to the game application and not your web browser, and the port number makes that happen. Port is an integer number between 0 and 65,535. Port 0 to 1023 are well-known ports. These ports are already reserved for some services, and it's recommended to not using them. It's not a big deal though, we have so many ports that we could use and there's no shortage of ports. So in short, in order to connect to a device, we need to know its IP address and we need to choose a port to use it for communication with that device. So when we want to connect two devices together, the first thing that comes into your head is probably that we're going to just connect them directly together. So this is called peer-to-peer. Although this method can be used in some cases, it's not very secure and it's not very scalable. For example, what if we have 3 devices? Or what if we have more than that? Things can get very complicated very fast for a large number of devices, and managing that type of connection is not going to be easy. So peer-to-peer is not something that we're interested in. We can just ignore it. So the better way that everybody is using these days is that we're going to introduce a third device. And then each of our devices are going to be connected to this third device, and we're going to call that one server, and we're going to call the devices that are going to be connected to the server clients. So we can connect as many clients to the server as we want. And basically, let's say this client wants to send a message to this client. It's going to send it to the server first, and then server is going to relay that to the target client. This is a very secure method, and it is very easy to manage. So as I mentioned before, networking is all about sending and receiving the data. So in networking, there are two ways that we can connect devices together and transfer data between them. We call that protocol. A protocol is a set of agreed upon rules that dictates how data is formatted, sent, received, and acknowledged. It is the language of the conversation. The two most fundamental protocols you will always hear about are TCP and UDP. They are like two different mailing services. Let's talk about TCP first. So in TCP, when you want to send the data from one device to another device, first the device A is going to send the data to the receiver. Then receiver is going to send a message back to the sender saying, okay, I received your data, but in UDP, the sender is just going to send the message to the receiver and that's it. So the differences between them is that TCP is connection oriented, which means before you send any data, first you need to establish a connection between those devices. But UDP is connectionless, which means you can just send the data without establishing any connection. The second difference is that TCP is reliable, which means it guarantees your data will reach the receiver. But UDP is unreliable, and sometimes your data might get lost. Another difference is that in TCP, your data will be received on the receiver in the same order that they were sent. But in UDP, the data don't have a specific order and there is no guarantee that they are going to be received in the same order. The next difference is that the TCP has higher latency. So basically it means it's slower. But UDP has low latency, which means it's a lot faster. So both of them are important and both of them are being used in different projects. For example, if you develop a social media app and you want to send text messages in that app, you definitely need to use TCP because you need to make sure every time that each user is going to type in a text and sends it, it's going to be delivered to the receiver. But let's say you want to have a video call using the same app. In that case, your video stream needs to use UDP because your video frames need to be sent as fast as possible. And in the middle of it, if some frames of the video got lost, it's not a big deal. It's not going to affect the video. Or another example, let's say you're building a video game. In this video game, when the player fires a bullet, you need to inform the server using TCP because you want to be absolutely sure that the fire event is going to reach the server. But let's say the player moves around and you want to synchronize the player position. In that case, you can constantly send the position of the player using UDP because even if some positions get lost, those positions that are going to actually make it to the target are going to be good enough to synchronize the position. So as you know, all programming languages have different types of variables. For example, we have strings, we have integers, we have booleans, and so many other variables. When we are working with TCP and UDP, we cannot just send any variable over the network. In order to send any data, first we need to convert it to a byte array. So it is actually byte array that is being transferred between different devices. For example, if you want to send an integer, first you're going to convert it to a byte array, which is going to be 4 bytes. Then you can send it over the network. It doesn't matter what number you choose. When you convert it to byte array, the length of that array will be 4 bytes. Another example would be string. When you want to convert a string to a byte array, you're going to have 1 byte per character. Floats also are 4 bytes. Booleans are just 1 byte. Either it is 0 for false or 1 for true. And another example would be short, that is 2 bytes. We have so many other variables that if we want to send them over the network, first we need to convert them into a byte array, and then we can send that sequence of bytes over the network. Let me give you an example. Let's say you want to send the data of a certain user from your server to a client. You need the username, you need the score, and you need a boolean indicating whether it is online or not. So in order to send this data over the network, first we need to convert them into a byte array. The first thing that might come into your head is that we're just gonna convert each of them into a byte array and send them separately. Although that works for some cases, but most of the time you want to send multiple variables together. So you need to convert all of them into a single byte array and send that one byte array over the network. And when you receive it on the other side of the network, you're going to convert it back to the original variables. So we usually call the combination of these variables that we send over the network packet. So the structure of this byte array, which we call packet, should be agreed upon between sender and receiver, and it is up to you. There is no rule, there is no checks by the network. Network is just a mailing service. It gets a byte array from you, it is going to deliver a byte array on the other side. It's not going to do any processing on those byte arrays. So you need to find a way to make sure the receiver knows what it is that you are sending. So because of that, we're going to create a packet ID. It is going to be an integer, and based on that packet ID, we decide what is in this packet. For example, we agree on this for ourselves. We're gonna kind of make a contract with ourselves that if the packet ID was 1, then we should expect a string username, an integer for score, and a boolean for is online. And they're going to be in this sequence, in this order, because order of these variables is important when we're gonna convert them into a byte array. So let's go ahead. The packet ID is 1. Then we know when the packet ID is 1, we're gonna expecting a string, an integer, and a boolean. And the packet ID itself is an integer, and we always set the packet ID as the first element in our byte array. Now, if we convert these values into a byte array, each one of them is going to be their own byte array. Now, if we combine them together, they're going to create a single byte array. So when we send this over the network, first we're going to check if our byte array length is greater than 4, because if it is not greater than 4, it means that this is not a valid packet. Then we're just going to ignore it. But if the length of the byte array is more than 4, then we know the first 4 elements are going to be the packet ID. We're going to get them, and we're going to convert it back to integer. It's going to give us the packet ID. Then with that packet ID, we're going to know what kind of other elements we should expect to exist in that byte array. Then we're going to grab them one by one. But there is one issue here. Let's talk about the string. As you know, the length of a string is not constant. The length of integer is always constant. It's always 4 bytes. But the string is depending on the length of the string. So what we're going to do, we're going to get the length of the string. Here it is Edward. It is 6 characters. Then we're going to convert 6 into a byte array, and we're going to insert it before the string. Using this, first, we're going to read the packet ID from the first 4 elements of the packet. Then we're going to process that and convert it to an integer. If the integer was 1, then we know that the next value in the array is a string. After that is an integer, and finally a boolean. And we know every time we're going to have a string, the first 4 elements before that is the length of the string. So then we're going to read the next 4 bytes. It's going to give us the length of the string. It is going to give us the number 6. Then we're going to read the next 6 elements and convert it into a string that gives us Edward. Then we're going to read the next 4 bytes. And finally, we're going to read the last byte, convert it into a boolean. This way, we can send data over the network using this packet system. So basically, we're gonna convert it to byte array, send it, receive it, and convert it back to original variables. It is simple. We can even introduce another step, which is compression. Sometimes we can compress the byte array before we send it. So when we compress it, it's going to be a lot smaller and it will be moved over the network a lot faster. So it would be smart to compress the large data, and then when we receive it on the other side, first we decompress it, then we're gonna convert it to the original variables. So that's it for this video. I tried to make it as simple as possible. This was specifically for beginners, for those who have no idea what is networking and how this system works. And since this channel is usually focused on game developments using Unity engine, I will also create a package for Unity for this type of networking. So I hope this video was useful for you. Please consider liking the video and subscribing to the channel. See you in the next video. Thanks for watching.